In this video, I'll cover how to multiply polynomials and monomials. It will help if you're already familiar with the rules for positive exponents. Here's two examples of multiplying monomials, or directions might simply say find the product. Here we have 5 times 7, and for multiplying the q's, we can simply add exponents. With our next example, we have 2 times 1, the number in front of the x if nothing's written. And then to multiply the x's, we simply add exponents. And to multiply the y's, we have 4 plus 5. Now we have two more examples where we're asked to multiply monomial by polynomial. That's what we have in the parentheses. Or they could simply say find the product. Regardless of what's written, when you have a number or variable outside parentheses, this indicates you're to multiply this by each term inside parentheses. So we'll distribute the 5q squared to each term. 35 q 2 plus 8, and then this term times this gives us a positive 20 q to the 5th. Here we'll be distributing a negative term, and there's 3 terms inside. So negative times a positive, this gives us a negative 6 y to the 9th. Negative times positive 1, negative 3 y to the 6th, negative times negative 24, and we just simply carry the y to the 4th. And notice with this example and this example, we had 5q squared times 7q to the 8th. But down here we were simply adding another term, so we just distributed to that as well. But we get 35q to the 10th for the first term in both cases. With these next 4 cases, they could simply say multiply polynomials or find the product. Technically, we have a monomial times polynomials or binomials down here, but they're probably just going to say find the product. But whichever case is written, basically parentheses next to parentheses means to multiply, so you'll distribute the 3x to each term and this positive 5 to each term as well. So 3x will go to x and the negative 4. And this 5 will go to each term. That'll give us a positive 5x. And positive times negative, we have 2 like terms we can combine. So 3x squared drops down. We subtract, get negative 7x, and this drops down. Notice this example's very similar to the one above, except that we have a y here and here, where we didn't up above. So it'll be 3x times x (3x times negative 4y) negative 12xy. When we distribute our positive 5y to each term, we'll have plus 5xy. I could write 5yx right here, but I prefer to just have them in the same order, so it's easier to identify like terms. And then negative 20y squared. We'll be combining our two like terms. So 3x squared drops down. That gives us negative 7xy and negative 20y squared. This example is similar to the previous two in that you lead with a binomial, but each of these terms is going to get distributed to the three terms inside parentheses. So we'll be distributing our 2x. This gives us 8x to the third. This will be a positive 12x squared. And then finally a negative 14x. Now as we distribute our negative 5 to each term, so with negative 5 times 4x squared, that's going to give us a negative 20x squared. I could put it out here, but often when I start having a lot of terms, I like to stack the like terms. So I'm going to put the negative 20x squared right here. Then we'll have negative 30x stacked under the like term. And finally, positive 35. It's blank above because it doesn't have a like term. So I simply draw a line and bring down terms or combine like terms. This would give us here the signs are the same. And we just bring down our positive 35. Down here my preference is basically to multiply these two binomials together and deal with this last. So I'll say 4x times 5x and 4x times negative 2. Positive 3 times 5x and positive 3 times negative 2. So I'll bring down my 20x squared. Combine these two like terms. Bring down the negative 6. This 2x to the third is going to have to distribute to each term. So I'll put a bracket here and then simply bring down 2x to the third. Now this is going to get distributed to each term inside inside the brackets. You could put parentheses here if you felt like it. So this gives us adding exponents. Remember, there's a 1 there, so that's to the 4th. And then finally, since we have multiplication indicated here and here, we can multiply in any order we choose due to commutativity of multiplication. So my preference is to deal with these binomials first and then bring down this 2x to the third and distribute it to each term. But I'll show you another way, very briefly, where you just distribute 2x to the third
to the first set of parentheses.
All right, so if we distribute 2x to the third to each of these, this gives us 8x to the 4th. Remember, there's a 1 up there. And then plus 6x to the third. This set of parentheses I have not touched, so I'll bring it down. And here, right now, it indicates that only 6x to the third is going to be multiplied to each term. So I need this in parentheses or brackets. And now, this says each of these terms has to multiply to each of these terms. So we'll send 8x to the 4th to each one. And what's that give us? X to the 5th. Because of the 1 there. And then negative 16 x to the 4th. And then we have to distribute 6x to the third to each term as well. So this will be a positive 30x to the 4th. I can put it here. And then finally, negative 12x to the third. Bring down 40. We'll be able to combine these two, so I'll bring this down. Combining these two gives us a positive 14x to the 4th. And we bring down our negative 12x to the third. And as you can see, we get the same answer. Again, I think it's a little more complicated when these values get larger and the exponent values get larger. I prefer this method. I think it's easier to keep up with and understand what you're doing. Now, for each of these cases, they may say multiply polynomials or find the product. They could also refer to them as special products. With this first example, notice the 3y's and the 7's are the same. It's just the signs here are different. So it helps to observe what happens when we multiply these two binomials. First, we distribute 3y to each term. And that gives us then we distribute our positive 7 to each term. When we combine these two middle terms, they cancel out. So we're just left with the next case here, we are going to have exactly the same thing because what's in parentheses is raised to the second power. Now when we distribute each of these terms, we get 25x squared and plus 20x Distributing our positive 4 to each term, we again get plus 20x, and finally plus 16. So now we'll bring down 25x squared, combine these two, and bring that down. Now for mixed practice, I'm just going to use the generic find the product. And you may be able to do these on your own. If you want to try pausing the video, that's fine. But I wanted to include them because sometimes the signs are different or the values are different. The exponents may be different than what I did in the previous examples. Looking at our first example, we'll have negative times negative, so this will be a positive 36y, and then 7 plus 1. Looking at our second one, we'll have to distribute this 4r to the third to each term. This will give us a negative 4r to the fifth. And then this would be positive 28r to the third. Looking at number 3, we have to distribute each of these terms to each of these. So 5x squared. This gives us, and then now distributing the negative 3 to each term. So negative 3 times 1x squared is going to be negative 3x squared. Notice for the x squared terms, I'm going to line it up here. Remember, I prefer to stack like terms, at least on the longer problems. And then so notice in this case we only had one like term. Sometimes that's how it works out. So mostly we'll just be bringing down terms. These are the only like terms we'll be combining. This gives us looking at number 4, we'll distribute the y to each term. Then we'll distribute negative 10 to each term. And we'll be able to combine these two like terms. So I'll bring down the y squared. Signs are the same. And bring this down. Looking at number 5, we have our parentheses raised to the second power, which means we have two sets of parentheses. Distributing our t to each term. Distributing -5 to each term. We'll be able to combine these, bring this down, and bring this down. Looking at number 6, distribute x to each term. Distribute this -y to each term. And I'm going to write this as xy. So when I multiply -y times x, I could write -yx, but I prefer to write -xy so it matches this term very clearly. And now notice what happens here. Once again, these terms are the same. The signs are what's different. The middle terms cancel out. So we're left with and looking at number 7, distribute k squared to each term. Distribute -6 to each term. And notice we have no like terms. So this is our answer. If you would like some practice with these concepts, as long as you're at my website, you can download a worksheet along with a detailed answer key.